Welcome back to the Scotti-BYTE channel, and this is Scott. I want to talk about something that is sometimes a little bit obscure but really helpful, and that is nesting inside of LXD containers. LXD containers are much more efficient than virtual machines in not requiring a full installation. They have nearly instant boot times, require less storage space, and also less memory. You can nest Docker inside of LXD and offer one or more Docker containers inside of a single LXD container. Nesting provides an easy way to give a Docker container a dedicated address without a lot of extra steps. And nesting Docker hosts provides some redundancy on your network in that you don't have just one Docker host, but you can have many Docker hosts. So in our demonstration today, we're going to create a LXD container, and we're going to start by creating a LXD profile for your main LAN. The command we're going to use is LXC profile create untagged, and we call it the untagged profile because it is going to be a profile that provides an address for your LXD container on the main LAN and not a NAT address as is the default. And then we're going to do a LXC profile device add untagged ETH0. ETH0 is the device name inside of a LXD container for the network device, the keyword NIC, and then NIC type equals MAC VLAN, and then the parent will be equal to whatever the name of the parent host network device is on the LXD host. Then we're going to create the LXD container using the new profile that we built with a LXC launch Ubuntu 22.04, which is the new Jammy Jellyfish version of Ubuntu server. And then we're going to call the container demo. We're going to use the default profile and also the new profile untagged that we created, and then set boot.autostart equal to true, which means that when the LXD host starts up, it also starts up the container. And then we're going to set security.nesting equal to true to allow our nesting. And then we're going to set the memory limits on the container to be 2048 megabytes or 2 gigabytes. You will adjust this accordingly depending upon the requirements of the Docker container that we'll be hosting inside of our LXD or any other applications you might be running. And then limits on the CPU allowance are up to 20% of our LXD host. And then we're going to add Docker to the LXD container. So in Ubuntu 20.04, adding Docker involved just running a basic Docker script on the Docker website, which is this curl command. However, in Ubuntu, and we also had to install Docker Compose separately. In Ubuntu 22.04, unfortunately, they had problems with nested Docker in all of my tests, but the snap works, and the snap also includes installing Docker Compose, so it can all be done in a single step. So we do a snap install Docker. The second step is that unfortunately the snap does not seem to add the system group Docker to our system to allow an unprivileged user to run Docker commands like Docker run and Docker Compose, so we add the group manually. And then after that we add the Docker group to a user, and in this case my user will be Scott, and so we do a user mod -a capital G Docker Scott to add Docker to the Scott account. And then we have to do a snap disable Docker followed by a snap enable Docker, and that will actually add Scott to that group. So let's go create a Docker container nested inside of a LXD container. Here we are at the command prompt on my LXD host. And the first thing we're going to do is a LXC list to list the containers that I have running on this particular host. And you can see that I currently have 3 LXD containers running. The other thing we want to look at is we want to look at LXC profile list to see the names of the containers that I currently have defined on this network. And you can see that I do not have an untagged container, which we're going to create next. Let's create our new untagged profile with the command LXC profile create untagged. So the next step is we have to determine what device or what parent device on the LXD host to use. And this system has quite a few devices attached to it. And so if I do an IP route command, I can look down here and I can easily identify, in my case, that the device that has the address 172.16.1.57 is actually the device that is on my main network, and it's called QVS0. So QVS0 will be my parent device, and then the next command that I use is the command that sets that new untagged profile with LXC profile device add untagged. ETH0 is the name of the network device inside of the LXD container. The keyword NIC type equals MAC VLAN, and the parent, as we discovered with the IP route command, is QVS0. Now that the untagged profile is created, we can do a LXC profile list, and we can see that our untagged profile exists. However, it might be nice to add a description to that, and we can do that by performing a LXC profile edit untagged. So this goes into the VI editor, and we can scroll down to where it says description and move inside of the quotes. The VI editor uses a lowercase I to put us in insert mode, and I can say main LAN untagged. Let's see if I can get this right. Main LAN untagged profile. And then to edit the VI editor, we do an escape, W to write the file out, Q to quit. And then if we do another LXC profile list, you can see that we now have our description next to our untagged profile name. To create our container, we use a LXC launch command. I'm specifying Ubuntu, 2204, the version of Ubuntu, Jammy Jellyfish. I'm calling the name of the container demo. I'm including the default profile in order to build the root file system, and I'm including the untagged profile in order to be able to get an address on our main LAN. And then I'm setting boot.autostart equal to true, which causes the container to start automatically anytime the LXD host is booted. I'm setting security.nesting equal to true so that we can nest containers inside of our LXD container. And then I'm setting the memory limits to 2048 megabytes or 2 gigabytes, and I'm allowing up to 20% of the CPU to be used. And this command is issued on a single command line. I hit enter. It says creating the demo container, retrieving the image, and now the container has been started. So in order to connect to the container, I can do LXC exec demo, the name of the container, bosh, and we connect to that container. The first thing we want to do, and also recognize that you're connected via the root device when you do the LXC exec command. So the first thing you want to do is an apt update. ampersand ampersand apt upgrade, and I'm going to put a -y to continue. And so that will perform the upgrades on the newly created container so that we know that it is completely up to date. Next, I'm going to add a user with the command add user Scott. And I'm going to give Scott a password. And just barrel through the prompts here. And then I'm going to do a snap install Docker. Now that Docker's installed, I want to do an add group system Docker, which goes ahead and adds a system group for Docker, since that isn't done by the snap. And then I want to be able to grant or add Docker to the Scott account with the user mod AG Docker. And then the next command that I need to perform is a disable on the snap for Docker, and then an enable. So now I want to do a few things to my container, and I'm going to start with installing Nano, apt install Nano. Sometimes Nano's installed and other times it's not. You can see here that Nano was installed previously. Then I'm going to install net-tools, and it goes off and installs net-tools, which gives us the ifconfig command. And then we're going to install neofetch. Just installing these tools to illustrate something we're going to do later on here. When you create a new container, normally the OpenSSH server is installed by default, but the problem with that is a lot of times that server has keys that are stale keys and need to be recreated. A really novice way to do that is simply by doing an apt remove --purge OpenSSH server. And then once we perform that operation, we turn around and we reinstall OpenSSH server once again with the command apt install OpenSSH-server. Let's test out a couple of the commands that we installed by doing an ifconfig. And we can see inside the container, we did in fact get an address on the main LAN of 172.16.1.65. Also, let's do the neofetch command, and we can see that we're running Ubuntu 2204 LTS, and you can also see how long my LXD host has been up and running for 29 days, 19 hours, and you can see some other details. Next, we want to exit the LXD container with an exit command to go back to the LXD host. And here on the LXD host, we can do a LXC list, and you can see that I have the demo container, and it is running at 172.16.1.65, as we also determined with the use of the ifconfig command that was installed through net-tools. So in addition to that, there's a very valuable capability that we have with LXD, and that's the ability to create or publish images. And you can say LXC image list, and you can see that I have some images on the system already. And what we're going to do is we're going to publish a new image. So the purpose of an image is all that work that we did with the LXD container in terms of adding programs, the Scott account, Docker, and so on, can be then saved as a starting point to create other containers. In order to do that, we have to do a LXC stop demo. So the container must first be stopped. And once the container is stopped, then the command is LXC publish demo. We're going to publish an image from demo. we're going to call the alias or the name of this particular published image Ubuntu-22.04-Docker to indicate that it is an Ubuntu 22.04 containing Docker, and I'm going to give it the description Ubuntu 22.04 with Docker and Scott account. I hit enter and it will go publish the image. Now that the image is published, I can do a LXC image list, and you can see that there is an Ubuntu 22.04 Docker, and by the way, the alias name cannot have spaces in it, and then the description is Ubuntu 22.04 with Docker and Scott account, just like we created, and that's all there is to it. Now, if we want to create another container that looks exactly like our demo container, we can do this command, which is the same LXC launch command that we had before, and we're going to call the name of the container this time demo2, but instead of saying go out and get Ubuntu 22.04, we're going to say start with Ubuntu-22.04-Docker, and it will create the container based upon the image that we just published. So now if we do a LXC list command, we can see that we have a new demo2 container up and running, and it has an address on our main LAN. And we also have the demo container, which is stopped because we had just exported or published the image previously for it. So we can do a LXC start demo. At this point in time, both the demo and demo2 containers have Docker running on them, the Scott account, and the other programs that we have installed, and that's the value of using the published image. Now, if we do a LXC list, we can see that we have both demo and demo2 up and running, and they both have unique addresses. But we have a problem here, and that problem may not be immediately evident, but what it is that if this container is running, or both these containers are running Docker, we should see a Docker device for them there, and we do not. So the problem is, in this particular case, that we needed to add a command switch onto the command line when we initially created the container with the LXC launch command. And since we didn't do that, we're going to go back and do a LXC config set demo security.privilege equal to true, and then that will go ahead and add the privileged container switch onto that container, and we'll do the same thing with demo 2. And then we'll do a LXC restart demo and a LXC restart on demo 2, and then both of those containers should be started up correctly. So you may not have this problem on your particular system, but it's a problem worthwhile understanding. So now we do LXC list, and what we were expecting to see with both containers is that we have a Docker device as well as an ETH0 device. Demo 2 hasn't quickly caught up yet, so we'll go ahead and do another LXC list command, and you can see that both containers have an ETH0 and a Docker device, which is really what we wanted. Now let's exit out of my LXD host with an exit command, and now we're back to my main system, which is my desktop computer. From here, we're going to do an SSH over to demo, and then you can see it's asking us if we want to connect, and we say yes. We type in my password, and I'm logged into the Scott account. So the reason I didn't say SSH space Scott@demo was because I'm on the Scott account on my local machine, and we created a Scott account on the remote machine. If I'd wanted to also store LXD keys, I could exit out of here, or not SSH keys rather, and I could say SSH-copy-ID to demo. I can type in my password. It says 2 keys have been added, and now when I do an SSH to demo, it automatically logs me in because it has SSH keys on the new machine. The entire purpose of creating our LXD dedicated containers was to be able to create Docker applications nested inside of them, and so I've selected a really simple application, which is Draw.io. And by convention, I usually like to do a makedir for Draw.io, or whatever the name of the application is. I cd into Draw.io, and I do a nano of docker-compose.yml, and then I'm going to paste the YAML code into it. This is very simple YAML code, and the one thing I want to point out to you is the ports that are used by this particular container. Now, if you watch Brian's channel, Awesome Open Source, frequently, you'll notice that he always says that you can't change the value to the right of the colon on the port number designations, because that is the port number that the author originally used when they developed the container, but you're free to change the number to the left of the colon to suit your needs in order to not have conflicts on your Docker host. But since we have a dedicated Docker host, all of our ports are available, so I simply made this ports 80 and ports 443 for our Draw.io application. I do a Control X, I say yes, save the buffer, I hit enter to write the file out, and it exits nano. At this point, I can do a docker-compose space up-d, and it will pull the container down from the Docker container repository and execute the app. Now, to test our app, we simply go to our web browser and we type in the address of the demo container, which is 172.16.1.65. When I hit enter, it accesses the app, and I can enter it and draw boxes and do all the things that this app actually does. So we were able to create a Docker container inside of our LXD and present it out onto the main LAN because of the choices we had chosen, and you can see that the application runs just fine and does everything that we want it to do. So in summary, we learned a simple way to create a LXD container that can host a nested Docker container on your main LAN. We used a Mac VLAN profile to expose the LXD container to an address on your main LAN. And then Docker inside of a LXD container running Ubuntu 22.04 required a snap for the containerd daemon to properly run. And LXD nesting is efficient and provides a nice way to isolate Docker applications on your network. Anyway, that's it for today. Please subscribe and like to the channel and hit that notification bell so you can be aware of new videos coming up.